Hello, geometry students. Today we're going to learn about the converse Pythagorean theorem, the exact opposite logic of the Pythagorean theorem. And we're going to use it to prove whether or not we have a right triangle on our hand. So the first thing we can do is say, hey, is this mystery triangle we're given, do the side lengths fit the pattern that we know it would have to fit if it was a right triangle? So we look at the two shortest lengths, short guy squared plus the next shortest guy squared, and we compare it to the longest guy squared. And if a squared plus b squared does equal c squared, then that proves it. We know we have a right triangle. So pause and let's see what this looks like in action. So the very first step when you're trying to use the converse Pythagorean theorem is to determine which side would be c. C would always be the longest, and in this case, c would be 85. And the next thing we do is we run a test. We put in our numbers, the two smaller guys squared, and add them together, and how do they compare to the longer guy squared? In this case, they're equal. And so the pattern a squared plus b squared equals c squared is shown, and that proves we've got a right triangle. So you practice with this problem and see what you think, and then press play for the solution. First step, we figure out who's the longest side. In this case, it's c. Then we run a test. The two shorter sides squared, add them together and compare, and we see that in this case, a squared plus b squared does not equal c squared. So this is not a right triangle. We can go even further, because if a squared plus b squared exactly equals c squared, then that is a right triangle. But if the c squared is too long, it would push open that angle, and we'd have an obtuse triangle. So if we run a test and the c squared is too big, that means we have an obtuse triangle. On the other hand, what if c is too little? If we run a test and the c is too little, then the angle will be too small, and it will be smaller than 90 degrees, and that would be an acute triangle. So here's a summary slide. Make sure to write these three theorems on your paper or take a screenshot. Now let's figure out if the triangle with these side lengths is acute, obtuse, or right. Steps are the same. First, we determine who's c. In this case, it's 14. It's the longest side. Next thing we do, we run a test. And in this case, we see that the c squared is bigger than the a squared plus b squared, so we know we've got an obtuse triangle. The c squared was too big, and so the angle was pushed open. Okay, practice again on your own paper and then press play for the solution. First step, determine the longest side. Who will be c? 9 in this case. Then we run our test. We try to see what pattern is showing up. A squared plus b squared, how does it compare to c squared? And when we run the test, we see a squared plus b squared and c squared. We see c squared is too little. So we have an acute triangle on our hands. Now, it can be harder if sometimes you can't tell who's the longest side. In this case, when you first look at it, it's optical illusion. You see the 11, you think maybe that's the longest side, but be careful. Use your calculator, because put in root 11, you'll see it's just 3, a little bigger than 3. Put in root 7, you see it's just a number a little bigger than 2. And so 4 is the longest side actually in this problem. That's a really important first step. Now you can run your test. Remember, square root and squaring undo each other, so out pops the 11. Square undoes square root, they're inverse operations, so out pops the 7. And over here, 4 squared is 16. And when we compare the two, we see that c squared is too little, so we have an acute triangle. So practice on your own paper and then press play for the solution. If you'd like some more practice, then pause and practice as many of these as you'd like, and then press play for the solutions. And I will leave you here with this cute picture of a lemon snuggling with Willow, and wish you a great day.